Okay, students, can you see my screen now? I believe you can see the screen right now. Today we have to discuss systems of linear differential equations. See, probably this will be the last topic of Laplace transform. But in 14th, there is another topic following from Laplace transform, which is application of Laplace transform. This topic will be a assignment 2. I'll give an idea about the application and then you will solve problems in assignment 2. Okay. Because you know how to use Laplace transform now. If you go through the videos of first 2 weeks of summer, first 3 weeks of summer, up to this chapter 4.6, first 2 weeks, you will understand all the basics of Laplace transform to solve a differential equation. Here it is slightly different. You are solving more than one differential equation at the same time. It's called a simultaneous system of differential equations. Simultaneous linear differential equation you can call it. See the problem number 1. There is a first order derivation in which both x and y, two variables, two dependent variable, one independent variable t, isn't it? So second differential equation is also in two variables y and x. So we have to simultaneously solve this one. A differential equation involves two dependent variables. So one alone cannot be solved. We need another equation. This is called a system or simultaneously solving. Okay, there are three problems. If time permits, we will solve all the three problems. Otherwise, at least two. Let's start with the problem number 1. Note down the problem. First derivation of x prime is equal to negative x plus y. X prime is equal to negative x plus y. And second differential equation, y prime is equal to 2x with some initial conditions. X of 0 is 0, y of 0 is 1. Okay, here we go. As usual, we will open the whiteboard and we'll start solving the problem as it is your choice. The problem, first problem, we are writing here. X prime is equal to minus x plus y. Second differential equation, y prime is equal to 2x. I have written dx by dt as x prime, dy by dt as y prime. There are some conditions, initial conditions. X of 0 is 0 and y of 0 is equal to 1. Let's take this problem. This is equation number 1. This is equation number 2. Take Laplace on both the sides. For equation number 1, take Laplace for 1 on both the sides. So what is Laplace transform of first derivative? Negative Laplace transform of a variable is x of t. This is x of t. X is x, but x is a function of t. So it will be capital X of s when you take Laplace transform. So y of t will be y of s. F of t will be f of s. And y prime, what is the formula for y prime? That should be written for x prime. S times x of s minus x of 0. The formula that we always write in y has been written in x right now. That's it. Capital X of x, capital small x of 0. And we know x of 0 has been given as 0. In the right side, it is negative x of s plus y of s. What happens on the left side? This term becomes 0. This x of s can join this club left side. So s times x of s plus another x of s from the right side, which is equal to y of s. Obviously, if you take x of s outside, it will be s plus 1 in the left side, which is equal to y of s. Therefore, x of s is equal to x of s is equal to y of s over s plus 1. This is our first result A. Keep this result ready for the calculations. Do the same for second differential equation and get x of s. And by using another these two rules, we can eliminate one variable and find the other variable. Okay. From second equation, take Laplace. For 2, what do you get? Laplace of first derivation will be s times y of s minus y of 0 is equal to 2 times Laplace of x, capital X of s. And what y of 0 has been given as 1. So the answer here it will be in the next step you get s times y of s minus 1, which is equal to 2 times x of s. We have derived x of s for the first equation. So here again we are going to get x of s. So keep the y and x separate. Y of s minus 1 over 2. 2 is divided on both sides. This will be x of s. Isn't it? This is our second result. B. From A and B, x of s is equal to this term. Both the sides, see, x of s is equal to this one. So equate this x of s. We are going to equate this term. When you equate that is from A and B, and we solve A and B, what is x of s here? Which is y of s over s plus 1. The right side, s times y of s minus 1 over 2. Okay, because both sides x of s, the result of x of s is given. So once they are equal, we have to equate them. Now solve, find an equation y of s, take Laplace inverse, you will get y of t. This algebraic equation, how to solve? Cross multiply. This 2 should be multiplied in the left side and this s plus 1 should be multiplied in the right side. So what do you get? Means 2 times y of s is equal to s plus 1 times s y of s minus 1. Put this term inside the bracket. Y of s. Two times y of s. We want y of s. So y of s should be calculated separately. S and y of s. Multiply this s into s square y of s plus s y of s minus s plus 1. Now let's rearrange. Let's take this term to the left side. It will be s plus 1 positive in the left side. This term to the right side. So when you take s square y of s plus s y of s minus 2 y of s. So s plus 1 on the left side. When you take y of s as a common term from all the three terms, you get s square plus s minus 2. Fine. Now we want y of s. What is y of s? This is capital Y of s. S equal to s plus 1 over s square plus s minus 2. This is what we get. Now we have to take Laplace inverse on both sides to get y of t. This becomes y of t. So we will get the solution y. And the solution x can be found by substitution method. Okay, first to factorize the denominator and use partial fraction method. Factorize the denominator. Let us write y of s plus 1 over s minus 1 into s plus 2. Can we factorize this term? So check s square minus s plus 2s will be plus s minus 2, isn't it? Now we have to factorize by partial fraction method. By partial fraction method. You find the numerator and write it here. What will happen? S plus 1 over s minus 1 into s plus 2 is equal to a over s minus 1 plus b over s plus 2. And solve this, cross multiply. Take this denominator s minus 1 s plus 2, multiply on both sides. We get left hand side s plus 1 or right hand side a times s plus 2 plus b times s minus 1. This is our partial fraction method. Now this is equation number 3 and this is equation number 4. Give some values for s, you will get the values of a and b. S is equal to 1. S is equal to 1 gives left hand side is 2. Here 2 plus 2, 4a, and s is 1. So it's 2, 3, 3a, 3a, b will be 0. This time will be, side will be 0. So a is equal to 2 over 3. S is equal to minus 2 gives S is equal to minus 2 gives minus 2. Why should I choose minus 2? Makes this term 0. That's why. Okay. Minus 2 plus 1 is minus 1 on the left side. A times 0. Minus 2 minus 1 minus 3 times b. This gives b is equal to 1 over 3. So when you substitute the values of a and b in equation number 3, what you find is equation number 3 gives, this is y of capital Y of s comes a is 2 over 3 divided by s minus 1, b plus b is 1 over 3 s plus 2. Now take Laplace inverse on both sides. Laplace inverse on both sides. Y of s will be y of t. 2y3 is a constant. Laplace inverse of 1 over s minus 1 plus second term 1 over 3 is a constant. Laplace inverse of 1 over s plus 2. Whenever there is 1 over s minus a or s plus a, it will be exponential. So the first answer is 2 over 3 e raised to t, because here it is negative. Second answer is 1 over 3 e raised to minus 2. That is the end of the problem. No, actually, we have found only y. This is a simultaneous equation, and we need to find x as well. Okay, let's go back and find the relation between x and y. X, very simple. We have used, see, come here. We know the relation. Equation number 1 as to y is x prime plus x. This is quite easy. Or here, x is y prime over 2. So from this equation, we can find x. X is y prime over 2. We have y. We have to differentiate y and find y prime. So that is it. So equation number 2 will give you an idea to solve. So we will solve by using equation number 2. Now equation number 2 gives x is y prime over 2. So differentiate y prime. This is our result. Equation number 5 is our result y. Y of t. Differentiate it. 2 over 3 e power t plus 1 over 3 e power minus 2t into minus 2 into minus 2. So what is x? X is and divided by 2. Divided by 2, there is a common division. 1 by 2, keep this 1 by 2 outside. So when you divide 2, you will get 1 over 3 e raised to t minus 1 over 3 e raised to minus t. This is the end. You have found both x and y. X is x of t, y is y of t. That's the end of this problem. Any question? Okay. Let's go to the power finder. There are 3 more problems. Problem number 3 is the similar way it should be solved. Check how we solve problem number 1. Okay, we'll take problem number 3 as well. Read the problem. X prime is equal to x minus 2y. Y prime is equal to 5x minus y, and initial conditions are given. And then we have a problem of second derivatives. I'll solve them one by one. Okay, let's see. So let me write the question first. What is it? X prime is equal to x minus 2y. Let me verify the question. Is it x prime? Yes, dx by dt is x prime is equal to x minus 2y. Y prime is 5x minus 5. 5x minus 5. and y prime is equal to 5x minus 1. Here the condition for x prime given x of 0 is -1, and for the second condition equation is y of 0 is equal to 2. Here we go to solve the problem. Usually what you do for Laplace transform, this equation number 1, this is equation number 2. Take Laplace transform separately and try. It is possible we can first solve these two equations, eliminate one variable, and then find Laplace transform. It is still possible, but better. Let's use Laplace transform here. Laplace transform of first derivation s times capital X of s is equal to capital X of s minus 2 times y of s. Here, I just missed one term here. The left hand side, it should have been s times x of s minus small x of 0. And x of 0 has been given -1. With the next negative sign, it will be s times capital X of s plus 1. And on the right side, x of s minus 2 times y of s. We need to eliminate either y or x. You can choose. Keep the y in the left side, isn't it? Minus 2 y of s in the right side, and then club all x in the left side. S times x of s plus 1 minus x of s. Take x of s as a common variable on the left side, you will find s minus 1 plus 1 is equal to minus 2y of s. So what is y of s? X of s into s minus 1 plus 1 over -2. Remember this result, this is result A. Let's do the same with the second differential equation. Laplace of y prime is s and y of s minus y of 0 is equal to 5 times x of s minus y of s. Substitute the initial condition y of 0 is 2. So this is s times y of s minus 2 is equal to 5 times x of s minus y of s. Here we are going to find y of s. So club them together, y of s. This y of s comes to the left side, s times y of s plus y of s. And this -2 will be in the right side, 5 times x of s plus 2. Y of s has been taken as common, and it's s plus 1. The right side it is 5 times x of s plus 2. Now what is y of s? 5x of s plus 2 over s plus 1. This is b. This result is b. Using a and b, let's eliminate y of s. Using a and b, this is a and this is b. Equate them. You get from a and b. What you get is the left hand side is x of s minus 1 plus 1 over -2 is equal to 5x of s plus 2 over s plus 1. Okay, cross multiply the denominators on both sides. So you get this term should be multiplied here with the numerator, and -2 goes into the right side. So x of s and s minus 1 into s plus 1, it will be s square minus 1 square. because s minus 1 a plus a minus b a plus b plus s plus 1 is equal to minus 10 x of s and minus 4. Now club x of s in one side. X of s square minus 1. This x of s should be taken to the left side. Is 10 positive 10 x of s, and this term s minus 1 should be in the right side. Minus 4 minus s minus 1. So take x of s as a common variable. This will be s square minus 1 plus 9, 10s plus 9. So minus s minus 5 in the right side. Therefore, we get x of s is equal to minus s minus 5 divided by s square plus 9. Further, we can separate this one. Minus s over s square plus 9 and minus 5 over s square plus 9. Now take Laplace inverse on both the sides. Laplace inverse gives x of s will be small x of t. Laplace inverse of this term, this is 3 square is 9. So it is cosine 3 to negative cosine 3t. Minus 5. 5 is a constant, I keep it outside. But here this is 3 square is 9. So we need a 3 in the numerator divided by 3. So 5 over 3 sine 3t. That is x of t. It's not done. We have to find y of t as well. X of t is done. Okay. What is y of t? The relation between x and y. Shall we use equation number 1 or 2? Let's verify one more time. Look at the equations. Yes, if you have this inverse y, we don't have y prime, y to find y prime. This inverse, first equation involves x prime and x to find y. So from equation number 1, we can write 2y is equal to x minus x prime. So y is equal to x minus x prime whole divided by 2. This is possible. So we have to find y prime, x prime, and then x minus x prime divided by 2 will be y. Here we go. Find x prime. Now we found x. The next step we will find x prime. Differentiate it. X prime is equal to negative cosine 3t. When you differentiate cosine 3t, what do you get? That is there is a negative. Cosine 3t will be minus sine 3t times 3. And minus 5 over 3. When you differentiate sine 3t, it is cosine 3t times 3. So what is x prime of t? When you simplify, it will be 3 sine 3t minus 5. This 3 and this 3 will be cancelled. 5 cosine 3t. Okay, from equation 1, we get y is equal to x minus x prime over 2. Check equation number 1, isn't it? This will give you a value. What is x? X is minus cosine 3t minus 5 over 3 sine 3t minus x prime first term minus 3 sine 3t minus and minus, it will be plus 5 cosine 3t whole divided by 2. You got to simplify this, and that's all. To find y of t, simplify this. Y of t is equal to let's little bit down so that club the sine and the sine cosine. There is minus cosine 3t here, positive 5 cosine 3t. It will be 2 cosine 3t. Now sine and the sine. And you take a minus sine 3t as a common term, then constant will be 5 by 3 plus 3, which will be 14 over 3. 14 over 3. 4 divided by 2. So this will be, first term will be 2 cosine 3t divided by 2 will be just cosine 3t. Did we miss anything? X is minus cosine 3t minus 5 over 3 sine 3t. X prime is minus, okay, when subtract minus sine 3 sine 3. 3 sine 3t minus and minus plus 5 cosine 3t 4 divided by. This is right. And the next step, it should have been plus 5. Okay, this is actually not 2, actually 4. Minus 1 plus 5. It should have been 4 times cosine 3t. And 5 over 3 plus 3. Okay, now it's doing good. 4 over 2, it will be 2 cosine 3t when you divide by 2. When you divide by 2. Next term, sine, this will be 3 cross multiply, 3 into 3, 9 plus 9 plus 5. 14 over 3 sine 3t over 2. So y of t, finally what you get? 2 cosine 3t minus 14 over 6 sine 3t. You can simplify further 7 over 3 if you want. Otherwise, stop here. That's the end of this problem. We found both x and y. The third problem is a second order differential equation in two different variables. Two different variables. So, what is the equation here? It is x double prime plus y double prime is equal to t square. X double prime and y double prime is equal to t square. So write this one by using the notation of x double prime, y double prime. Rewrite, and then there are 4 conditions: 2 for x and 2 for y. Simultaneously, we will solve this problem. Okay, let me write this problem in this class. The question I am writing on the board. The question is, x double prime plus y double prime is equal to t square. That is first equation. Second one is x double prime minus y double prime is equal to 4t. This is equation number 2. When you see the equation 1 and 2, when you add these equations 1 and 2, y double prime can be eliminated, isn't it? And we can solve x double prime, find x, then substitute in any of the equation to find the y value. Initial conditions: x of 0 is equal to 8, x prime of 0 is equal to 0. Here y of 0 is equal to 0, y prime of 0 is equal to 0. Let's start solving this problem. Sum them up. Equation 1 plus 2. You get x double prime, here x double prime, 2 times x double prime. Y double prime negative y double prime will be 0. And the right side t square plus 4t. This is now the third equation. Take Laplace transform. Obviously, second derivative, Laplace of second derivative. Take Laplace. Laplace of second derivative. 2 is constant. S square x of s minus s small x of 0 minus x prime of 0, just like y. And what is Laplace transform of t square? 2 factorial is 2 over s cube. Okay. 4t, 4 times 1 over s square. Now divide this entire equation by 2 because there is a 2 here. Divide by 2 will give you, and substitute the values of x of 0. X of 0 is 8, x prime is 0. S square x of s minus 8s, third term is 0, is equal to 1 over s cube plus 2 over s square. We divide by 2 both sides. This keep x of s on the left side. Everything else should go to the right side, isn't it? Okay. In the next step, we will write s square x of s is equal to 1 over s cube plus 2 over s square plus 8s. Now x of s should remain on the left. All other s square should be divided here. S raised to 5 plus 2 over s raised to 4 plus 8s over s square. It will be 8s, 8 over s. Now take Laplace inverse. We know everything is the powers of s, so you'll get t, isn't it? So Laplace inverse on both the sides will give you small x of t in the left side, which is Laplace inverse of t raised, see Laplace inverse of 1 over s to the power n plus 1 will be t to the power n over n factorial. So n plus 1 is 5, so n is 4. T raised to 4 divided by 4 factorial. You can find the value of 4 factorial. 1 into 2 into 3 into 4, which is 4 factorial. 6 into 4, it is 24. Now this is 2, is a constant. S power 4, it is 3 t cube divided by 3 factorial plus 1 over s is a Laplace transform of 1 is 1 over s. So this 1, 8. What is x of t? T raised to 4 t raised to 4 divided by 24 plus 2 and 3 factorial is 6, so it will be t cube divided by, no, we can leave that. We can stop here. Factorial, when we need it, we will make it. This is 4 factorial. Stop here for x of t. We'll go for y of t now. Y double dash of t. Let's go and check the combination of x and y. Okay, if you know x, and you can still find only y double dash, and there is no y involved, so Laplace transform should be used for y as well. Now let us add this to. Okay, we have x, we have, we can use another way as well. There are two methods to continue. You can now eliminate. Now first, we eliminated a y double prime and go on with this one. Here we can eliminate x double prime. 1 minus 2. What will be happening? 1 minus 2. Check. Question 1 minus 2. Let me try here. This is x double prime minus x double prime to 0. Y double prime minus of minus y double 2y double prime equal to t square minus 4t. Isn't it? T square minus 4t. So when you divide, okay, let's go ahead with this one. From 1 and 2. Equation 1 minus 2 will give us y double prime is equal to 2y double prime is equal to t square minus 4t. Therefore, y double prime is equal to t square over 2 minus 2t. Get another equation. Two numbers. What was the last one? 3. This is x of t is 4. And this is 5. Now again take Laplace transform. Laplace transform for y. Y double prime s. So Laplace gives s square y of s minus s small y of 0 minus y prime of 0. Now use the initial conditions. T square over 2. Laplace 1 by 2 is constant. 2 factorial is 2 over s cube. 2 over s cube minus 2 1 over s square. Y of 0, what is the value of y of 0 and y prime of 0? Both are zeros. As far as we know, both the terms are zeros because only one initial condition is non-zero. S square into y of s, these two are zeros, is equal to 1 over s cube minus 2 over s square. Therefore, y of s is equal to 1 over s raised to 5 minus 2 times 1 over s raised to 4. Take Laplace inverse on both the sides. You will get the final answer, y of t. Y of t is equal to This is 5 t raised to 4 over 4 factorial minus 2 times 3 t raised to 3 over 3 factorial. That's the end. Is there 2? Yes, there is a 2. That's the end of this problem. That's the end of this problem. I think all the 3 problems that have been chosen for system of linear equations have been solved, and that completes our Laplace transform. Thank you very much, and we have one more period to go. And I was planning to start Bessel's function, Bessel's equation, which is next week topic. And if you like, we can start tomorrow, because tomorrow we have again 2 more periods. Today, I will give you one more problem to solve. You can solve right now yourself. Just show me the answer. Okay, fine. The last step actually is 3 factorial. Okay. 3 factorial can be simplified with the 2. It's possible. Okay, you can still keep as it is. Okay, that's the end. That's the end. You guys have any question right now? Hello? You have any question?
Yes, hello, doctor.
Yes. Hello, how are you?
Fine.
Whether my voice is clear, is it audible to you when I solved the problem?
Yeah, everything is
Okay.
clear, doctor.
That's good. And this is like just yet another YouTube video. Okay, you can watch any number of times. It will be available on Blackboard. Okay, I will show you here in this corner. There is a menu, isn't it? Menu. If you look at here, go to recordings. You will find whatever the session completed. After the completion of 1 hour, isn't it? If the session is over, it will update after 1 hour. Then go to the recordings. You will find all recorded videos. You can see. Go to the particular course section. Maybe sometimes it is theoretical, sometimes it is practical. Go there and go to virtual classroom. Here, the recordings in this menu, isn't it? You can find the recorded videos live. You can watch any number of times, just like your YouTube videos.
But doctor, it is better to upload it in YouTube.
But the problem is we couldn't upload this link in the YouTube. I tried. This link couldn't be downloaded. Otherwise, I have to change the strategy. I don't teach live. I will upload only videos. We will discuss only doubts in the live. What is your suggestion? If you guys approve, I will do another thing. I will do my own recorded videos on YouTube. And during the class, I will show the same YouTube videos.
Yeah, it is better
Because
this way.
it's better. How many of you vote for this? Because 1 or 2 may not be good. If all classes, all the students in the class agree, we go with that one. Some other students mailed me that they want videos on YouTube. That's good. But the UGC suggests, I mean, Jewel University College rules suggest us to go with live classes. Okay, gentlemen. As many of you guys asked, I will do one thing. From Bessel function onwards, I will record the video. I will record my video and I will upload on YouTube. But there is a live class. We cannot cancel live class. Live classes will give you attendance.
Yeah, okay, no
It is
problem.
compulsory. And during the live class, I will just telecast my recorded video. Is it good?
Yeah, it's good.
Okay, fine. If you guys like that one, it is up to you because you are the learner. I want to provide the material the way you like. And you must see the next week you will have deadline for quiz one, assignment one, I think. Check or read the instructions before submission of anything. Here, okay, I go with recorded videos for the next class onwards. Hmm. If you have any other question to discuss, you can spend the rest of the class for discussions now.